Okay. So in the problem of minimizing a function fx for a single variable x, let assume a point. This is the point. You have to calculate what? Fxk. Okay. F dash xk and f double dash xk. Right? Okay. Yes. So if xk is any initial root, right? Then next root will be xk minus f dash xk upon f double dash xk. So based on this single formula, you will solve all the problems of Newton method. Okay. First note this formula. Derivation is not important. Only how to use it is important. Okay. Okay. So Newton method works well if f double dash x is greater than 0. Okay. Newton works well. Understood? However, yes. But if f double dash x less than 0 for some x, Newton method may fail to converge. Sometime converge, but not always converge. But when f dash x is 0, it always works better. Okay. Okay. So sometime this formula can be written as xk minus gxk g dash xk. What is gxk? Is nothing but f dash x. So f dash x is replaced by g dash. You will get same thing, right? Yes. Note this also. Why you are writing in this way? Because when g of x is equal to 0, this is called Newton's method of tangent. Okay. Newton method of tangent. I tell you with an example. Okay. See, what are the steps or you can say Newton method algorithm. Okay. So first step is what? Choose initial guess. Initial guess means any initial value of x is given, or sometime you have to choose from your side. And this is called x in bracket 1 and a smaller number epsilon. Epsilon is any you can say limiting value. Okay. Set k is equal to 1. Compute f dash x1. Okay. Step number 2, compute f double dash xk. Understood? Step number 3, calculate xk plus 1. Use the formula. Which formula? Xk, f dash xk. Understood? F double dash xk. Right? After finding x raised to k plus 1, find, compute f of f dash xk 1 plus 1. Understood? Step number 4, if absolute value of f dash x k plus 1 is less than epsilon. Epsilon means the smaller value you choose already. Less than epsilon, then you can terminate. And otherwise, else set k, do for second iteration. Okay. Repeat two step two. What? X the power k. Where? Here. X x to power k means in first iteration, uh, you are going closer to closer, more closer value of x. Okay. For example, between k is equal to 2. No, this is actually symbol. Okay. X raised to, let, you can say this is first iteration. This is second iteration, like this. Understood? Yes. So note these two steps. After this, we will do with an example. So you will repeat the process until you get this fourth step. And epsilon is always given in the question. Epsilon is called accuracy. So repeat the process until you get your value is less than epsilon. Epsilon, epsilon is not fixed. It is given in the question. Okay. It is very least value. Okay. Okay. Using Newton's method, find the minimizer of fx. Let the initial value x0 is equal to 5.5. Okay, this is 0.5 and the required accuracy be 10 raised to minus 5. Okay. Okay. Accuracy means the different. Let's suppose you solved up to fourth iteration. Then x3 and x4 point. When you subtract, you will get 5 decimal place same value. Understood? Okay, I tell. Suppose you solved this problem and you got x3 is equal to 1.12345 6, for example. Okay, and x4 is 0.12345 8. So you can see uh, first 5 decimal places are same. When you subtract this, you will get what? Always take absolute value. You will get point, right? And this is what? Less than 0.5. Understood? Yes. Whenever it is given, it means uh, the consecutive root are 5 decimal places are same, have same value. Okay. Yes, because accuracy is given. That's why we have to solve according to the question. Okay. Okay. Now see, fx is what? Right. F dash 6. Right. And this is f double dash 6. Understood? Okay. Create a table like this. Okay. Right here xk. Okay. Then f dash xk. Then f double dash xk. Understood? Here you will use the formula. What is the formula? Xk minus f dash xk F double dash X. Understood? And always check fourth step is what? Less than epsilon. Understood? So let's suppose K is 0. Okay? K is K. This is X0. Uh, you can also write this X0. Both are same thing. Okay? Understood? Yes, yes. X raised to 0 means what? X0. X raised to 1 means what? X1. So according to Newton method, you can write in this way. Only representation is same. Representation is different, but both are same thing. Understood? So X0 is what? 0.5. When you put here 0.5, tell me the value of f dash x. No, no, no. Cos 1 by 2. This is not cos inverse 1 by 2. You have to use calculator here. Solve using calculator. Yes, cos 0.5. Always, in which mode your calculator is? No, always solve in radian mode. Yes. Whenever you use calculator in engineering mathematics, always write in radian mode. Okay. Shift mode. Yes. 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 Minus and find the value of this in double derivation. 1.4794. Okay. Now find x1. X1 means what? X0, f dash x0, right? F double dash x0. And you have everything. X0 is what? 0.5 minus 0.3775 and then 1.479. Solve this and tell me the value. What do you get? Okay. Very good. Okay, check whether this is less than, this is not less than, right? That's why go to next iteration. Next iteration is what? 0.7552, right? Yes. Now put this value here and here. Understood? So when you put in first derivation, you will get 0.0271. Check. And 1.685. Check both the value. So always give in this form in the exam, okay? Check only first value. Okay. No need to check further because I calculated. Now x2 will be, you can verify later, no problem. F dash x1, F double dash x1, right? So when you put 0.752 and all these value, right here, okay, what will you get? 0.7391. Is it less than sorry, 10 raised to minus 5? No. Okay, then go to next iteration, right? Next iteration will be 0.7391. Okay, and when you put here in f dash x, you will get 9.461 into 10 raised to minus 5. And when you put here, you will get 1.763. X3 will be, after putting all these value in the formula, right? You can check. First three decimal place are matched, right? Na? But still this is not less than. Okay. Yes, yes. Okay. The fourth step will be 0.7390. And when you put here 1.17 into 10 raised to minus 9, which is very less than 1.763. Okay. 0.7390. You can see here, third iteration and fourth iteration are matched, right? So you will get here. Yes. Understood? Therefore, you will stop here. The minimizer of given function is x3 is approximately equal to x4. Understood? Points. Yes, yes. Only check this part. At which point? This point, this value. Okay. Yes. Yes, yes. Okay. Yes. Write all these. And you can verify that the last x raised to 3 is same or not. Here. No, no. Put. Acha. Which one? When you put here. Okay. No, it's 9.4. Put here 0.73.